This video is going to walk through our problems from the probability practice and sort of talk through my thinking as I approach these various probability questions. So the first two questions are just sort of stereotypical probability. We're looking at rolling a dice and sort of what is the likelihood of certain events happening. Now, for all of our probabilities, we're going to be writing them as fractions and then also as percents. So that you get exposed to both answers. All right, so we have a single dice is tossed. So I pasted in this chart here. This chart actually looks at two different dice being tossed together, but we're going to just focus on this top right here. So these are the possibilities if you roll a single die. You got 1, 2, 3, 4, 5, 6. So there are 6 possibilities. Now, we're here asked basically the probability that a number is less than 5 given that, remember that little line there means given that the number that comes up is even. So if I'm focused on this, I want to start and focus on how many even numbers are there. Well, in this case, there's 2, 4, and 6. So I know that there are 3 even values. And of those 3 even values, 2 of them, 2 and 4, are less than 5. So the probability that if you rolled an even number and it would end up being less than 5 is 2/3, or 66.7%. Next one. So now we're going to be focused on rolling 2 dice at once. Now, how this chart works is that it's sort of giving you different outcomes. There are actually 36 different possible outcomes when you roll 2 die. And I like this chart because it shows like a red dice and a white die, because keep in mind, it could be that you got a 1 on the white die and then a 2 on the red die, but it's also a possibility to get a 2 on the white die and a 1 on the red die, and those are different outcomes. So we're focused on our conditional probability here. So all of these are given certain settings. So I'm going to start by highlighting sort of so we can focus on this sort of limitation. So here we're a 5 on the second die, given you rolled a 5 on the first die. So I'm going to imagine die number 1's the white die. So all of the outcomes with 5 on the first die are these right here in this column. And there are 6 possible outcomes here. So there are 6 outcomes. Now, the probability that I also got a 5 on the red die, there's only 1 outcome then. And so this would end up being 1/6, or 16.7%. All right, next one. We're going to erase so we can start again. Sum of the dice is at least 8. All right. Now, there are charts you could look up online that sort of sum up the dice for you, but I figure I can sort of do it on my own. So I got 6 and 6, that's 12, so that's at least 8. And then you got 6 plus 5, that's 11. 6 plus 4 is 10, 9, and at least 8. So I would include 8 in that combo. And you can sort of go through and, any below here, and I'm just sort of... And so we end up with these are all of our possible things. And we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 different combos that end up with a sum of at least 8. Now, how many of those are actually doubles? So if we go through and we got 6 and 6, we have 5 and 5, and we have 4 and 4. So there are 3 that end up being doubles. So we have 3 out of 15, which ends up being 20%. Last one flips this around and says, sum of at least 8, given that you rolled a doubles. So in this case, what we'd end up with, so we have all of our doubles, and so the doubles are sort of right here along the angle, and 6 and 6 is a double. 5 and 5. 5 and 5 is a double that adds up to at least 8. 4 and 4. So of those 6 doubles that we had, 3 of them had sums of at least 8, which gives us a percentage of 50%. All right. So that's just some examples of conditional probability involving rolling of dice. I highly recommend if you're, giving yourself that little sort of visual when you're sort of going through and counting and thinking about the likelihood of something. All right, the next few we're going to go back to sort of making Venn diagrams or looking at contingency tables and using those to help us build our probability. So on this one, we have 70 students that were surveyed about watching sports. 50 said they liked watching football. So one of our circles is going to be football. And the other circle is going to be for soccer. So we have 50 students who said they like watching football, 20 students who said they liked watching soccer, and 5 who said they liked both. So Venn diagrams, we like to start in the middle. So we got 5 in the combo of both. If 20 liked watching soccer and 5 are in the overlap, that leaves 15 over here who only like watching soccer. Same idea with football. If there are 50 students who like watching football and 5 are in the overlap, 50 minus 5 would leave 45. And you need to do a quick check to see if we have any extra students who don't like either. So we got 50 within the football circle plus 15 over here in the soccer only. That would lead us with 65. That's not quite the total because remember there were 70 students, and so there are 5 students who don't really like watching either. All right, so now we're going to go through and we're going to set up fractions and then turn them into percents for our probabilities. So likelihood of picking someone who likes football, there were 50 students who liked football out of those 70 who were surveyed. And if I did 50 divided by 70, I would find out that percent would be about 71.4%. Only like football versus just like football. Only like football means we're going to be focused just on that number on the outside there. And so here we'd end up with that 45 out of 75, 70, a little fewer, which would end up being 64.3%. All right, then we have a like both. So another way to think about this would be the probability that they like football and soccer. Oops, it helps if I spell soccer right though. S-O-C-C-E-R. So that's just another way to word that same thing. So this would be, it's the overlap we're looking at now, just that 5 in the middle there. So it's 5 out of the 70, which would end up being 7.1%. All right, D then is saying likes football or soccer. So that's anyone in our circles. So basically everyone but the 5 on the outside. Well, the 5 on the outside minus the 70 is probably a little easier to figure out, which would put us at 65 out of 70, which is basically 92.8% of the people. All right, last but not least, we're going to take a look at a conditional one using our Venn diagram. So this time we have likes, given they like football, how many like soccer? So given they like football means we're only focused on things within that football circle. So that means I'm only focused on those 50 kids who said they liked football. And of those 50 kids, 5 of them also liked soccer. So it'd be 5 out of 50 or 10%. All right, so that was an example of doing some probability along with our Venn diagram. The next one's going to be one that focuses on a contingency table. And this contingency table has contestants in a dog race. So we have our basset hound and female. So this is looking for an overlap. So basset hounds and female, there are 12 out of the total 44, which would end up being 27.3%, versus basset hound or female. In those cases, we're going, we're focused on sort of both either or situations. Now you want to be careful here. There's two different ways to approach this. One, you could just add the three numbers, so the 10 plus 12 plus 8. And, so I'd have 10 plus 12 plus 8 all over the 44. Or another way you could think about it is some people like to say, well, there's 20 females and there's 22 Basset Hounds. But in doing both of those totals, I added that 12 in twice, so I'm going to subtract the 12. Either way is going to get me the right probability. They're just sort of two different ways to think about the problem. In both cases, you'd wind up with 30 out of 44, or 68.2%. Alrighty, now we move on to some conditional. So we're saying a Basset Hound given that it's a female. So the female here means I'm going to be focused purely on this top row. So we know that this is out of 20, and of that 20, how many were Basset Hounds? Well, 12. And that would then get us a 60%. Similarly, let's just change the color. If I wanted to say, what is the likelihood of it being female, given that it's a Basset Hound, now we're sort of focused on this blue column with a total of 22. And we have that same 12 there that are female of those 22. So 12 out of 22, which would be 54.5%. And those are the problems on page 1. Stay tuned for the next video where I will walk through the questions on page 2.